Hi everyone, I'm Melissa Illingworth. This is my video on density. So what weighs more, a pound of feathers or a pound of bricks? When you were 5, you'd say bricks and be wrong, because I just said you have a pound of each of them. The weight is not different between these two things, but the density is. The density is a combination of two different measurements: mass, a measure of how much something weighs, and volume, a measure of how much 3D space that object takes up. I'm going to find now the density of a few objects. I'm going to start with this piece of aluminum. It's actually a solid cube of aluminum. We can find its mass with a balance, a scale. And now to find its volume, this is a cube. Each side is the same length. You might remember from geometry class, length times width times height to find the volume. For this object, it's 1 inch on each side, or 2.54 centimeters. When we calculate that, it gives us a density of 2.71 grams per centimeter cubed. This could also be called cubic centimeters or cc's. On an old medical show, you might hear, give me 3 cc's of adrenaline. It's the same thing. So for a geometric solid like that, we can use an equation to find its volume, combine that with the mass to find the density. But what about something like this? This is a rock I found outside. There's no equation that can give me the volume of this rock. I can find its mass easily enough. But now finding its volume, we're going to need to do something different. So like any scientist, you would read about what has been done on this subject before, whether this problem has been solved before. And this problem, how to find the density of something irregular, has been solved actually over 2,000 years ago by a Greek mathematician and philosopher called Archimedes. And we can use his ideas, they work just as well today. This is a graduated cylinder. It's a piece of glass with some markings along the side that measure volume. And right now it has 30 milliliters of water in it. This rock takes up some space, some volume. When I add it to the water, it will sink to the bottom and it will displace some of the water. It's going to shoot the water level up just a little bit. We'll be able to measure by the markings exactly how much the volume changed. So I'm going to add this rock carefully so it doesn't splash. There. And now read the new level. So rock plus water is 33 milliliters. We can subtract and find now the volume of just the rock. And that's what we want to use in our density calculation. So now I can find the density of a rock of some kind of irregular solid. And now maybe this density would help me find out the identity of that rock, what it's made out of. One other thing I wanted to show you guys about density is that no matter what form the material is in, what shape the material is in, its density is always the same. So these are 2 different samples of the same material, copper, pure copper. This is a cube of it, and these are some little pieces of wire that are all twisted up, but they're also pure copper. So they won't have the same mass, they won't have the same volume, but their density will be almost exactly the same. So that's the mass of this copper cube. Again, like the cube before, it's 2.54 centimeters on each side. And that works out to be 8.96. For that cube of copper. Now, here are these two pieces of copper wire. I'm going to weigh them together. And here's another graduated cylinder that has exactly 30 milliliters of water. I'm going to add these two pieces of wire. Again, try to get no splashing there. And look at it really closely to find the new volume. So this part of copper here is 8.86 grams per milliliter. It's very close to 8.96, and our accepted known value of copper. With even more precise equipment, we could find that they have the exact same density. All right, thanks for watching.